Good evening, and welcome to the another session of mathematics. In this session, we'll see some more problems on mathematics, starting from question number 61. Okay, so for those who are already practicing the previous sessions, can pause the video and try to solve this problem. Go ahead. So this problem is asking us, there is one equation given here, integral 0 to x, and then 2x into f square, and this big quantity, and f of 1 is given to be 1, and f of x is differentiable function for all x positive, and f of x is increasing function for all x positive. Then there is a sequence given. Then we need to see which of the options are true. So we'll now go ahead. So our main point to start with this. So 0 to x, we have here 2x into f square of t dt is equal to this integral from 0 to x, and then we have here 2 times. So f of x minus t, we can apply King's, then we'll get this. Now this could be written as further 2x integral 0 to x f square t dt would now be equal to, we'll take 2 common, and then I'll be having here 4, and then this entire integration turns out to be 0 to x simply, and then f of t dt the whole square. That's what I have. Now I'll try to cancel this 2 and this 4 and get 2 here. So this eventually gives me integral 0 to x, so x squared, x into f squared. So x into f squared t dt is equal to 2 times integral 0 to x f of t dt the whole square. Okay, just to confirm. Yeah, so 0 to x f of t dt the whole square. Let's start differentiating this. So of course, by Newton-Lenz's rule, you will be having here derivative u as it is, derivative of v will be f square x, so the derivative of v this plus u v part will remain as it is, and then derivative of u is simply 1. It's equal to, here this will be 2, and then one more 2 will be followed, integral 0 to x f of t dt, and then the integration of this differentiation of this quantity, which is simply f of x. That's what we have. And now if we see here, then this quantity x into f square of x, and then this part and this part, they share a close relation. Maybe I'll think of this part here, or else let's simply go ahead, no problem. So x into f square x, we will see what happens at the end. I'll transfer this here, so I'll get minus 4 times integral 0 to x, and then f of t dt, this into here f of x, and then plus integral 0 to x f square t dt is equal to 0. Now this looks like a quadratic equation in f of x. So this is a quadratic in f of x. That means I could get f of x like this. F of x will be equal to, so it is 4 times integral 0 to x f of t dt, and then plus minus square root of, this would be b square, which is 16, and then integral 0 to x f of t dt the whole square minus, this is going to be 4 x into 0 to x f square t dt. This will be having here 2x. Now our main concern is this guy inside the square root. So if you see carefully, then we can write down this one in this format. But writing this one, the second expression, second term in this first term, okay, we have some strong benefits because that is whole square, so we can just take it out. So I'll write that part from here. So that means I need to arrange how much? I need to arrange 4 times x into f square. So 4 times x into f square, we can get it from here. From here. So simply this expression I have is, I can take this x inside, so there is no harm. So 0 to x, x into f square t dt is equal to 2 times integral 0 to x f of t dt the whole square. That's what we have. So now if I want this quantity 4 times, so I'll just multiply this equation by 4. So this equation I'll multiply by 4. So 4 divided to x, this will be 4x into x squared dt. That turns out to be simply 8 times integral 0 to x f of t dt the whole square. So that means now I can write down this quantity as 8 times this entire quantity. That means I'll be having here f of x is equal to 4 times integral 0 to x f of t dt, and then plus or minus, this will be 16 minus 8, which is 8, that is 2 root 2, and then square root of 0 to x f of t dt. So this is ultimately going to be modulus. Okay, but ultimately my function is defined in 0 to infinity. It's increasing in 0 to infinity. That means it has to be positive. So modulus will be positive. This and then whole over 2x. That's what we have, which we can reduce further and write down in a nice looking form. So this looks like 2 plus minus root 2 and then integral 0 to x f of t dt over x. So my f of x will be simply, I'll multiply x here. So x will be x into f of x is equal to 2 plus minus root 2. So 2 plus minus root 2 and then integral 0 to x f of t dt. Now from here, the intuition is quite clear that we again have to apply the Newton-Raleigh's rule. That means we'll differentiate on both sides. So differentiating both sides. The moment I differentiate this, this will become x, and then this will become f dash plus f of x will be here as it is. Derivative of x is 1, which is equal to 2 plus minus root 2, and this guy will turn out to be simply f of x. We can transfer this to the side. This gives me f dash of x is equal to 2 minus 1 is 1 plus minus root 2 into f of x. Now we can integrate our function. So this equation is good. This x and now integrate both sides. So this would give me ln of f of x is equal to 1 plus or minus root 2 into ln of x plus we can write the constant as ln of some k. And now for this part, I'll be having f of x is equal to. So this will be x to the power 1 plus minus root 2 into k. So that was the condition given. That is f of 1 is given to be 1. So I'll plug it here 1. So 1 is equal to simply k. So that means my function is f of x is equal to x to the power 1 plus root 2 or x to the power 1 minus root 2. But since x is defined to be a positive function in 0 to infinity, so that means this guy, if you see that it decreases, so minus root 2 is more than 1. So this guy will be rejected. But that's not an increasing function in 0 to infinity, so we have to take this guy. So f of x is x to the power 1 plus root 2. So, okay, let's take this guy then. So f of x is equal to x to the power 1 plus, we'll keep it reserved. So we have broken the half of the problem into the chunks. And now the next part will begin. So we have here Tn is a sequence such that Tn plus 1 is equal to Tn plus root of Tn square plus 1. So I have here Tn plus 1 is equal to Tn plus root of Tn square plus 1. It's given that T0 is equal to 0. This is 0, then it's perfect. So that means we now need to find out the Tn because ultimately we need for this part is fine, this part is also fine. So now our main concern is about this tk. That means we need the nth. Well, that means we need the compact form of the sequence. So of course, if you look at this sequence, then here T0 is 0. So let's find T1 here. So T1 would be T0, which is 0 plus the square root of 1. That turns out to be 1. And if I find T2, then T2 turns out to be it is 1 plus the square root of 1 plus 1, which is 2. So that turns out to be root 2 plus 1. So if you see here, then 0, 1, root 2 plus 1, I cannot generalize this into some direct form. Okay. So basically, it's not just any algebraic polynomial we can get. This requires another kind of substitution here. So if you look at this, then Tn plus 1 equal to Tn plus root of Tn plus 1 square. Tn plus 1, Tn square plus 1. So if I put Tn is equal to tan of some theta n, I can plug in cot of theta n basically. So I can plug in any one of them. So we don't have any problem. But we should see which we can generalize. So if we watch it carefully, then the sequence is basically, look at this. So if I plug in here cot theta, I have no problem here because with cot I'll be having this thing. Okay, so 0, 1, and root 2 plus 1. So if I take Tn is equal to, let's say, suppose if I take cot here, then I have here pi over 2 to the power, because I need to have 0 at the beginning, and then it should be 1. For 1, it should be 1. For 2, it should be root 2 plus 1. So this gives the intuition of somewhere that this is pi over 4, cot pi over 4 is 1, or say tan pi over 4 is 1. T0 is 0, so say pi over 2 is 1. This is pi over 8 somewhere. Root 2 plus 1 and root 2 minus 1. They both are related to cot. That means I'll think of generalizing this sequence. So can I take Tn is equal to cot pi over 2 to the power additive, so that I get 0 is equal to 1. And at 1, I should get pi by 4. That means I'll write down here pi n plus 1 basically. So if I take Tn is equal to cot of pi over 2 to the power n plus 1. So this gives me, if I plug in here 0, then I get cot pi by 2, which is 0. So yeah. And then T1 is equal to, so this is 1 plus 1, 2, pi by 4 is perfect. This is pi over 8, which is 2 plus 1. So yeah, this is my sequence. Tn is equal to cot of pi over 2 to the power n plus 1. So my sequence. So the next part would begin. So we need here f of n to the power root 2 minus 1 first, because these two things require it. Also, first I'll try to find out this thing first. What is this guy, by the way? So f dash of 1. So if I look at the expression, so ultimately we have found both of them, f of x and t. So I'll now write down here. So my f of x is basically x to the power root 2 plus 1. And my tn is cot of pi by 2 to the power n plus 1. So we have found everything. Now I need to differentiate this. So f dash x will be equal to simply root 2 plus 1 into x to the power root 2. So 2 minus 1. This one gets cancelled. And I need f dash of 1. That turns out to be root 2 plus 1. So we need 1 over f dash of 1 will be equal to 1 over root 2 plus 1. That can be written as root 2 minus 1. Now root 2 minus 1 holds a special place in terms of tan. So if you look at this, then tan 22.5. Tan 22.5 is root 2 minus 1. So we need to write down in the proper form. So this is tan 22.5 is pi over 8. So tan pi over 8 is root 2 minus 1. And I need to get this in terms of cot. I need to get this in terms of cot inverse. So I write down in terms of cot. So with cot, I can write down here cot of pi by 2 minus pi by 8. This will be again root 2 minus 1. So this turns out to be, okay, yeah. So cot 3 pi by, so 3 pi by 8 will be equal to what? Root 2 minus 1. So that means if I look at this thing, so cot inverse of 1 over f dash of 1, it's going to be basically 3 pi over 8. So A option would be incorrect. If that is not pi by 8, that is for tan. This is for cot 8 is 3 pi by 8. And now we'll go for this guy, tk over 2 to the power n minus 1. It's everywhere. So we'll find out first f of n to the power root 2 minus 1. So f of n to the power root 2 minus 1 will be equal to n to the power root 2 minus 1 into root 2 plus 1. That turns out to be simply n. So this quantity is n now. So that means if I look at this here, then I have tk. Tn is basically cot of. So Tn is cot of pi by 2 to the power n plus 1. That's what we have. So if I plug in here, so I'm going to have, and this is k. Now k is ultimately n, so I don't have to worry. That is simply Tn only. So okay, that means if I go and solve this part or this part, so I have limit n tends to infinity tk. So that turns out to be simply cot of pi over 2 to the power n plus 1 over 2 to the power n minus 1. This could be written as limit n tends to infinity. Then I'll try to balance this. So cot I'll be writing in the denominator. So I get tan of pi by 2 to the power n plus 1. And this 2 to the power n minus 1 I'll be writing like this. 2 to the power n plus 1 into 2 power minus 2. Okay. And then this part I'll be writing here 4 times limit n tends to infinity. And then 1 over, this will be tan of pi over 2 to the power n plus 1 into 1 over 2 power n plus 1. So I'll multiply here by pi and divide by pi. So this gives me tan theta over theta, which is 1. So I get 4 over pi. It's going to be equal to 4 over pi. And that makes my option C correct. So when C is correct, then automatically D is incorrect. Let's go to the next problem. And in the next one, 62. So we have limit n tends to infinity. R starts from 2026. So sigma R is equal to 2026 to n. Where we are R1 over RC 2026. So now if this thing is in the denominator, then we have a lot of formula, but when it's in the this thing is in numerator basically, but when in denominator we have nothing to do. That means idea is to get the telescope. So idea is to telescope it. Because without telescoping, we won't get the value directly because we have no such formula. So let's try to telescope it. So for that thing, what I'll do, I just have to think of some pattern which gives me this thing. So recall. So if I have NCR minus 1, got this. NCR minus 1 survive. So if I write NCR into NCR minus 1 over NCR into NCR minus 1, this could be written as 1 over NCR minus 1 minus 1 over NCR. This is what we know. So NCR minus NCR minus 1 over this thing is equal to this guy we know already. Now I have to arrange this guy somewhere. That means what I'll do, I'll multiply and divide by R plus 1 over R throughout. This one also. And this guy also. So R plus 1 over R. So I'll now multiply and divide. So idea is to get the telescope here to this side. That means I'll be working on with this guy. So we can now write it. R plus 1 over R into this 1 over NCR minus 1 over NCR would now be equal to R plus 1 over R, and then this quantity NCR minus NCR minus 1. We need one more thing here. So if you recall this property that NCR plus NCR minus 1 is equal to N plus 1 CR. Now, if I have this thing here, so I have NCR plus NCR minus 1 is equal to N plus 1 CR. So if I use this thing here, particularly, so I have CR minus CR. Well, I have minus here. That means this is not the correct telescope. So we won't be getting from here. So this idea won't work. Apply the other approach. Still the same thing, but in a different way. So if I consider this part, so I have instead of NCR minus N minus 1 CR, this one over N minus 1 CR into NCR. This could be again due to this note. So 1 over N minus 1 CR minus 1 over NCR. This we could write. So now if I apply here, so NCR minus N minus 1 CR, so I think this works. Now step 1 is this, and we also need here NCR plus NCR minus 1 is equal to N plus 1 CR. So we'll apply here this one. So now again, I have this portion. So what I'll do, I'll multiply and divide by R plus 1 by R on both sides. So I have here 1 over N minus 1 CR minus 1 over N CR. Please watch it carefully to understand why I have written this r plus 1 over r. So if I multiply on both sides, so I'll be having here r plus 1 over r, then this part can be written as NCR minus n minus NCR minus 1. So NCR minus n minus 1 CR over n minus 1 CR into NCR. Let's keep it. So this would be r plus 1 over r. Okay. And NCR minus n minus NCR. This I can now write down if I look at this expression. Okay. Say I'm writing in the different format. Right here. Okay, so if I transfer this one to that side, so I get n plus 1 CR minus NCR. So I'll be eventually having NCR minus 1. So if I compare this one numerator NCR, instead of n I have n plus 1. Instead of n plus 1, I have n here. So if I write down in that format, I have NCR minus n minus 1 CR. So this is going to give me n minus 1 CR minus 1 basically. This over I have here n minus 1. This I'll take it in the denominator. This is the r plus 1 here simply. And then r within the denominator. And then here I get n minus 1 CR. And this NCR we can use the property n over r. And then n minus 1 CR minus 1. We'll use another property. And it is this. Sorry. In case if you do not know, NCR will be n over r, and then n minus 1 CR minus 1. This I used, r minus 1. Now, this part and this part gets cancelled. This r and this r also gets cancelled. So I'm only left with r plus 1 into, this is r plus 1 over n minus 1 CR minus 1 CR, this, and then into n. Of this guy, I can bring it down like this, 1 over r plus 1 basically here, and this n I'll keep it here, then 1 over n minus 1 CR. So the same property now I can apply reverse. So I'll be having n minus 1. So this is basically n C. So it'll be r plus 1. I'll be having it here. The same property, I can just pull it. So n over r plus 1 and then n minus 1 CR. So I get this thing. That means we have written this entire expression is equal to simply this guy. Because now we have r plus 1 over r. Then in the sigma, I have 1 over n minus 1 CR. So 1 over n minus 1 CR minus 1 over NCR. NCR. This thing we have written 1 over NCR plus 1. So now if you look at the base here, what do we need? R is what? 2000. This thing is 2026 everywhere. So here we have to put R is equal to 2025. So I'll now be having 2026 over 2025. This, then 1 over n minus 1 C 2025 minus 1 over n C 2025. This is equal to 1 over n C 2026. So that means now my entire series gets converted to, we can write here h equal to 2026 to infinity. 1 over n C 2026. Now I can write down 2026 over 2025. This, and then sigma n is equal to 2026 to infinity. I have here 1 over n minus 1 C 2025 minus 1 over n C 2025. This is what I have. Now if I consider this portion, then this is actually a telescope property. So solving this part, you can consider some specific location here, say K or particularly R, and try to do the summation here and then get it cancelled. Or else ultimately you could write down 2026 over 2025, this into. So if I start from 2026, so the first term I'm going to get here is 1, then minus, this is going to give me NC, N is 226, C225. This plus blah, 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 blah. Everything gets cancelled. And at the end, I get here 1 over NC 2025. Now you could take the limit. So for the limit, this part becomes 0 and I get only. So this entire portion is simply 1. So that means my answer would be here. This thing P over Q is going to be 2026 over 2025. So therefore, P is equal to 2026 and Q is equal to 2025. That's what I get. So I get, and now if I add both of them, so I get P plus Q is equal to 4,000. Oh, wait, what? 26 and 25. So, 47, sorry. Yeah, 4,047 I get. So which is definitely less than 4096. So correct. That's again correct. And now look at this one. So limit k tends to 0 plus p to the power q over k. My goodness. Okay. So p to the power q over k. So let's write down. So limit k tends to 0 plus. We have here p to the power. P is 2026. So 2026 power 2025 over k. So over k plus 2025 to the power 2026 over k. 26 over k on this whole power k. So this part now we need to solve. So this will solve to be this is k tends to 0. So we can write down now limit k tends to infinity. And this is same as 2026 to the power 2025 to the power simply k plus 2025 to the power 2026 to the power k and then whole power 1 over k. So we have changed the limit. So now we just need to see here. So suppose if I have here a and I have here say b, and I want to find out limit n tends to infinity. Say I have here a power n plus b power n to the power of n. So if I look at this thing, so this is infinity to the power 0 form. So ultimately, my goal is if a is more than b basically, then I can think of taking a common, and this entire series gets converted to simply. So here two cases will be there. Either a will be more than b or b will be more than a. So in that case, I get the limit as simply max of a comma b. Okay. So max of a comma b. So if you want the practical demonstration like this is not fine, then I'll take one example for you. We could write 3 power n plus 4 power n to the power 1 over n. Now, of course, I see here 4 is more than 3. That means I can take 4 power. So 4 power n will be common, and I'll be having 1 plus 1. 3 over 4 to the whole power n to the power 1 by n. Separate this from the right. So this will be limit n tends to infinity. I get 1 plus 3 over 4 to the power n to the power 1. So this part becomes 0 and 1 over 0 will be 1. So it's just simply 4, which is nothing but the max of a and b. So that means now we need to see which one is bigger, 2026 power 2025 or 2025 power 2026. So which is bigger? That's the entire limit now. So we have 2026 power 2025 versus 2025 to the power 2026. So let's establish which one is bigger. So for that thing, whenever we see this power comparison, we will directly go to the application of derivatives and we can construct the function. Say f of x is equal to x to the power 1 over x. So if I differentiate this, then this will become x to the power 1 over x as it is. So it's like function to the power function differentiation. So here, when you have function to the power function, f of x power g of x differentiation, you could simply differentiate by keeping f of x as variable, g of x as constant. So the derivative would be g of x and then g of x minus 1 into f dash of x plus, and again one time you keep f of x as variable, f of x as constant, g of x is variable. So it will be this to log of f of x into g dash of x. That's what we get. So we can apply directly here. So it will be x to the power 1 over x. So keep this one as constant, this one as variable. So x power 1 over x into log x, and then minus 1 over x square plus x to the power 1 over x will be as it is. The derivative of 1 over x would be at the bottom, and this will be minus 1. So that's what I get. So over x has to be x to the power 1 over x. And now I have to equate this to 0. So I can take x to the power 1 over x common, and I'm left with log x by x square in minus. This x power 1 is gone. I get here 1 over x square in plus. This is equal to 0. So we can keep x to the power, or else at the moment this is not required. Don't equate to 0. There is no point. We have to adjust this function. So f dash of x is going to be this. So f dash of x is equal to x to the power x and then 1 minus log x over x square. So I know that this part is always positive. Also always positive. That means everything now depends upon 1 minus log x. So if I look at the graph of log x, it goes this way. That means this guy is 1. This becomes at e, this gives me 1. So here, if I look at the chart here, then this is e. So before e, after e, log becomes more than 1. So after e, the derivative decreases. And before it is positive, so it increases. That means, so x is equal to e is a point of maximum for this function. So that means my function is decreasing in e to infinity and increasing in 0 to e. So f is increasing in 0 to e and decreasing in e to infinity. So now, of course, I know my 2025 is less than 2026. So this implies f of 2025 will be more than f of 2026. Yes, f is decreasing in this interval. So this is going to be 2025 power 1 over 2025 is going to be more than 2026 power 1 over 2026. So now we'll take the power here. So this will be 1 over 2025, and then it's more than 2026 to the power 1 over 2026. So now, if we look at this here, I take here 2025 into 2026 power on both sides. So for that case, I'll be having this cancelled, and this one, this will cancel. So this proves that 2025 power 2026 is more than 2026 to the power 2025. So if I look at this, then this is my Q, and this is P. So Q to the power P is more than P to the power Q in our case. So the one which is max, so max is this, that's the limit. So answer would be Q to the power P. Q to the power P. So yeah, so D answer will be correct. That means C is incorrect. I hope this makes sense. Let's go for the next one. Now we have a look at this 6/3, and here this hefty integral is there, and then there is another component omega. So this is based on getting this value first. So this is going to be some k pi. We need to bring k from here. Let's put it here. Then we need the value of this component. So not step to do. So if I look at 0 to infinity, this is ln of 1 plus x to the power 11 or 1 plus x to the power 3. This, and then here 1 plus x square into it is simply ln of x dx. So now for such things where we have log and some kind of function, the eventual part would be to use the component 0 to infinity. F of x dx can be now taken as a substitution. Yep. So you could write here 0 to 1 first, f of x dx, plus then we write 1 to infinity, f of x dx. Now the goal is to convert this 1 to infinity integral by using the substitution as x is equal to 1 by t. this integration can be again converted to 0 to 1 f of 1 by t minus 1 over t squared dt. That is the goal. So we'll break it here, then 0 to infinity. This is ln of 1 plus x to the power 11 over 1 plus x to the power 3. This, and then we have 1 plus x square into this is ln of x dx. Now I'm going to break it in the form of 0 to in two pieces basically. So 0 to 1 I'll go, and then 1 to infinity. So 1 to infinity, I'll be having ln of 1 plus x to the power 11 over 1 plus x to the power 3. This over 1 plus x square into ln of x dx. That's what we have. So now this is our toy today. Let's play with it. So here in this part, I'm going to take x is equal to 1 by t. So if I take x is equal to 1 by t, my dx would be minus 1 over t square dt. My limits will also change. That means this integration now gets converted to, so this is going to, when I put x is equal to 1, this is giving me 1. But when I put infinity, this gives me 0. So it is like 1 to 0. And here I have minus, so I'll change the integral limits and I'll write them from 0 to 1, ln of 1 plus 1 over t to the power 11 over 1 plus 1 over t to the power 3. This, then 1 plus 1 over t square. Then I have ln of 1 over t square. Then dx will be minus 1 over t square dt. But now since we have changed the limits, this is no longer minus, it is plus. And since now I'm going to deal with this guy, so this is the next page. Now this thing we can further reduce to 0 to 1, and then this will be going to be, this is going to give me ln of, this is t power 11 plus 1 over t to the power 3 plus 1 into t to the power minus 8 over, this is going to give me t square plus 1, and then this t square gets cancelled with this t square. So okay, and this is ln of t square, we can write here minus now, because ln of 1 over t is minus. So now we'll break it. So I'll write here integral 0 to 1 ln of t power 11 plus 1 over t power 3 plus 1. This over t square plus 1 into ln of t square. No, this I know t square is getting. So I have to here see what's on the other. The x is 1 over t, so this simply 1 over t square. So if I move further, I end up getting this thing. And then here I'll apply log of m into n rule. So I'll be having minus. So this gives me basically minus of minus is plus. Then again integral 0 to 1. This will be 8 times. I get ln over again t square plus 1 into ln t dt. So now the second part actually we have converted to this part, and then this part is equal to this minus plus. And if you look at this part and this part, this eventually gets cancelled. That means this entire expression is now equivalent to simply 0 to 1. 8 times over 1 plus t square plus 0 to 0 to 1. Oh yeah, 0 to 1 over t square dt. So that's what we get. And now simply if I solve, then I'll be having this LNT also gets cancelled. And this gives me 0 to 1, 8 times 1 plus t square dt will now come to be 8 times tan inverse of d. And limit goes from 0 to 1. So if I plug in 1, I get here pi over 4 and then minus 0. So this turns out to be 2 pi basically. Means my k is 2. So we have succeeded in the first chunk of the problem. Now let's go for the second one. So that is some omega given to be cos of 2 pi over 7 basically. So now the next problem starts. So we have here omega is equal to cos of 2 pi over 7 plus I times sine of 2 pi over 7. So I could write down e to the power I 2 pi over 7. So omega is equal to e to the power 5I over 7. So if I take the seventh power, I'm going to get here 1. That means omega is seventh root of unity. So omega is seventh root of unity now. So if I start applying the properties of roots of unity, then I get here some of the roots. So 1 plus omega square, omega cube, omega 5, 4, omega 6 is equal to 0. That's what we have. Now there are components defined here for the same problem, and alpha turns out to be 1, 2, 4. So if I choose 1, 2, and then 4, then that is my alpha. So alpha is equal to omega plus omega square plus omega to the power 4. And beta is going to be 3, 5, 6. So let's take 3, 5, 6. So 3 and 5 and then 6. That means we have succeeded in getting 1 plus alpha plus beta is equal to 0. So from here I get alpha plus beta is equal to minus 1. Now I want 2AB, so by the common sense, I'll be squaring this. So alpha square plus beta square plus 2 alpha beta is equal to 1. So that means if someone gives me alpha square plus beta square, I'm done. So alpha square plus beta square can now be written as alpha square plus beta. From here I get minus alpha minus 1. So I can write here alpha plus 1 square. So this is basically 2 alpha square plus 2 alpha plus 1. So if you look at alpha square, then this is going to be 2. Alpha square will be omega square plus omega 4 plus omega power 8. So if omega power 7 is 1, so omega power 8 will be omega. So I get here omega, and then plus 2 times omega cube plus 2 times omega 5 plus 2 times omega 6. So we've got this thing, and then plus 2 times alpha. Alpha turns out to be, again, omega plus omega square plus omega 4 plus 1. So now if you look at this, then this is 2 omega square plus 2 omega square. 4 omega square, 4 omega 4, 4 omega cube, 4 omega 5, 4 omega 6. So all of this turns out to be this much multiplied by 4. So this total is 4 omega. So I get this entire quantity as minus 4 plus 1, which is minus 3. So alpha square plus beta square is basically minus 3. Now one should not be under the impression that this is the non-negative quantity. Alpha and beta are complex numbers, so they can be negative. So that means alpha square plus beta square is minus 3. So I get 2 alpha beta is equal to 1 minus 3, which is 4. But minus 2 alpha beta turns out to be 4. So the answer will be 4 here. Let's go to the next problem. So look at this. So here we have another beautiful problem. We have a function y equal to f of x, and then it satisfies dy over dx minus integration from 0 to f of x dx is equal to f of x. So for such problems, we will start with the most basic thing, that from integral 0 to 2 f of x dx, of course, I'm going to get this some constant, so I'll say c. This part turns out to be dy over dx minus c is equal to f of x. So you could write dy over dx is equal to c plus f of x is y. So this is now simply a variable separable differential equation, and I can integrate on both sides. So this gives me ln of c plus y is equal to x plus some k. So now I get c plus y is equal to some constant into e to the power x. So y will become now a into e to the power x minus c. So now again I can plug it into this equation. So I have 0 to 2, and that is a into e to the power x minus c. And then dx is equal to c. So this gives me a, and then integration of e power x will be e square minus 1 minus 2c is equal to c. So I get a into e square minus 1 is equal to 3c. So that means we have taken this part as c. So I need the value of c ultimately. Anyhow, so let us see what we can get through here. So we'll use the condition f of 0 is 1 here. So if I use 1 of f of 0 is equal to 1, I get is equal to a minus c. So I have this equation. I want the value of c basically, so I'll put a. A is equal to C plus 1. Let's plug in here. So I get C plus 1 into E square minus 1 is equal to 3C. So which means E square minus 1 is equal to 3C upon C plus 1. We can invert this. So we have E square minus 1 is equal to C plus 1 over C, and then 3 will be here. And now we'll break it. So I get 1 over C is equal to 3 over E square minus 1, then minus 1. So I get 1 over C is equal to 3 minus E square plus 1. This over, I get E square minus 1. So this gives me 1 over C is equal to 4 minus E square over E square minus 1. So C is going to be E square minus 1 over 4 minus E square. So if I multiply here, I get 4 minus E square into C is equal to E square minus 1. And if you look at the problem carefully, then it is 4 minus E square into C. So that means we already have landed up with this guy. So I just need to take the GF of E square minus 1. So E square turns out to be nearly 7 point something, point something. Minus 1 will be 6 point something. So 6 point something GI, if I take, then it is going to be 6. So I hope the second clear. Now we'll go for the next problem. Get this one. So question number 65. So we have one equation, and we have 3 real roots, alpha, beta, gamma, and they are in HP, and that's what information we have. That's it. So we need to get all these informations. So let's look at this. So I have x cubed by bx square plus qx minus q is equal to 0. So say it has got 3 roots, alpha, beta, and gamma. So even if we have no idea, still we will think about the sum of roots. So alpha plus beta plus gamma is going to be plus minus, so minus p. And then alpha, beta, gamma is going to be cube. Then the dual sum, alpha, beta, beta, gamma plus alpha, gamma is going to be cube. Okay. So now if you look at this, all right. Okay, now since they are in AP, sorry, not AP, HP, alpha, beta, gamma are in HP. So they're in HP, that means 1 over alpha, 1 over beta, or 1 over gamma are in AP. So since Q is non-zero, that means none of alpha, beta, gamma can be 0. So let's go ahead. That means 1 over alpha plus 1 over gamma is equal to 2 over beta. So now if I just little modification, if I see, then I can sense I should add 1 over beta on both sides to get 3 over beta. Now this quantity I should be more familiar with, because that is alpha beta plus beta gamma plus gamma alpha over alpha beta gamma. And that turns out to be 3 over beta. So this is q over q. So beta is equal to 1 into 3, which is 3. So beta is equal to 3 I have. For one root, for other 2 roots, so I don't see any conclusion can be made. We use all the informations. So let's go ahead and at least I can think about this option, I guess. Since beta is 3, so I can plug in here 3. So this gives me 27 plus 9p plus 3q minus q is plus 2. Q is equal to 0. So if it's a root, it must satisfy the equation. So just put in the original equation. So I got my option B correct. Now look at this one. So 1 over alpha square, 1 over beta square, 1 over gamma square. So one may think of that to find the expression actually whose roots are 1 over alpha square, 1 over beta square, 1 over gamma square. We can think of, but I guess that will be a bit cumbersome task, because ultimately we don't want the perfect roots. We just want the inequality. So if I look at this thing carefully, then we might think about AMGM, but 1 over alpha square, 1 over beta square, 1 over gamma square, right? At GM, it won't help us. So we need 1 over alpha square plus 1 over beta square plus 1 over gamma square. So if I just see here 1 into 1 over alpha plus 1 into 1 over beta plus 1 into 1 over gamma, the whole square is less than or equal to 1 square plus 1 square plus 1 square into 1 over alpha square plus 1 over beta square plus 1 over gamma square. This inequality you must be aware. It's called Cauchy-Schwarz inequality. So that means now I can clearly see then this is 1 over alpha, 1 over beta, 1 over gamma. I know them. 1 over alpha, 1 over beta, 1 over gamma is simply what? This is 1. That means I know that 1 over alpha plus 1 over beta plus 1 over gamma is 1. So this must be. So I can just simply plug in here. So this is going to give me 1 and then this is 3. Then I get here 1 over alpha square plus 1 over beta square plus 1 over gamma square. So here, this actually completes my problem here. This thing is greater than or equal to 1 over 3. So this makes my option A correct. Now let's go for C. So there is this requires 1 over alpha, beta and all. So by the common sense, we have alpha, beta, beta, gamma, gamma, alpha. That means I should think of squaring 1 over alpha plus 1 over beta plus 1 over gamma square is equal to 1 over alpha square plus 1 over beta square plus 1 over gamma square plus 2 times 1 over alpha beta plus 1 over beta gamma plus 1 over gamma alpha. I know that this quantity is 1 and is equal to 1 over alpha square plus 1 over beta square plus 1 over gamma square plus 2 times 1 over alpha beta plus 1 over beta gamma plus 1 over alpha gamma. I want this guy, so I'll transfer this one to that side. So I get 2 times 1 over alpha beta plus 1 over beta gamma plus 1 over alpha gamma is equal to 1 minus 1 over alpha square plus 1 over beta square plus 1 over gamma square. Now I want the maximum value of this. So for the maximum value of this guy should be minimum. So the minimum of this is 1 over 3. So we have solved in the first problem. Yeah, minimum is 1 over 3. So I'll simply think of plugging it here. So this gives me 2 over 3. And then the inner intuition should be to cancel these two ends to politely and say 1 over alpha beta plus 1 over beta gamma plus 1 over alpha gamma is greater than or equal to 1 over 3. And oh, okay, wait. This is max thing. So minimum is this thing. That means I'll be having a less than or equal to actually. So I'm finding the maximum. That means this guy should be minimum. So this guy should be less than or. That makes my option C also correct. Turn to P over Q. So if I see P over Q, then it is eventually alpha plus beta plus gamma over alpha beta gamma. So if I see here, P over Q, and this turns out to be alpha plus beta plus gamma over alpha beta gamma. This is mine, so now I think that is perfect. P over Q, so P is my alpha beta gamma negative. And then if I just simplify this, then this gives me 1 over alpha beta plus 1 over beta gamma plus 1 over gamma alpha. This is minus P by Q, and just now we have proved that this is less than or equal to 1 over 3. So that means I know when minus P by Q is less than, that means P over Q is going to be greater than or equal to minus 1. The correct sequence, yes. So this is also correct. That means all 4 options are correct in this problem. All right. So that's all. So this Sunday evening we have solved these 5 problems. I hope your preparations are high. Wish you all the very best for your JEE Advanced next week. In between, if I get some more time, I'll post some more videos. Thank you so much for watching. Happy learning.